Okay, I have one more last example. I'd like to write absolute value as a piecewise defined function. In order to do this, we have to remember a little bit about how we compute the absolute value of any number. Hopefully you remember that if you take the absolute value of a positive number like 4, that the absolute value of that number just spits the number back out. So the absolute value of 4 is 4. The absolute value of 6 is 6. The absolute value of 8 is 8. Absolute value of 12 is 12. So the absolute value of x is x when x is greater than 0. But what about negatives? Right? When we take the absolute value of a negative, what we get back out is the positive value. Because remember, absolute value is defined as the distance a number is from 0. And so distance is always positive. So that's why we get absolute value of any number is going to give you something positive. But let's return to our negative situation. Absolute value of a negative we need to make positive. Mathematically, the way we do that without using the absolute value symbol is we take the negative of the number. So absolute value of -4, in order to make that positive, we take the negative of -4. Gives us the positive number. If our number is -8, what we would do to make it positive is we would take the negative of the -8. If our number happened to be -15, we would take the negative of -15 to get the positive. So if our number x is negative, we do -x to make it positive. That's exactly what my piecewise definition says at the bottom of the window. It says if our x's are negative, we throw a negative in front of them. So for the x's that are negative, we take the negative of them, and that makes it positive. For the x's that are positive, we spit them out just the way they were. So if we put in x, we get out x. The interesting one is 0, and I want to talk about what I did here. If I take the absolute value of 0, I get back out 0. So we could argue that it fits into the positive situation because what goes in comes out. Some textbooks, and our textbook actually did this, says, well, we could put the absolute value, or not the absolute value, the equality on the negative line, the x less than 0 line. Because again, if you take the negative of the number 0, it's going to be neutral anyway. So this is one of those where it doesn't actually matter because the two pieces are going to meet one another right at 0. Some people put it on the less than piece. Some people put the equality on the greater than piece. Please don't put it on both pieces. So you would pick one. Now, I didn't do that in my notes, but let's just briefly talk about what this would look like if we graphed it, because we will need this later on in the course. And so later on in the course, we're going to need what the graph looks like, and this is as good as time as any to graph it. Right? If I were to graph the absolute value function, I'll set myself up with a set of axes. I think I'll just change my color to do this. What would happen is the graph would look like this here and this here. Not a really great drawing, but these two pieces would meet right at 0, and so I get this V shape. So remember, absolute value gives you the V shape. Again, our x-axis and our y-axis. So just a quick reminder of what the graph would look like. So now you can go off and work on the problems that I have asked you to do for section 2.3.